we go. There we go. Okay. For question number 1, we are describing the function up, down, left, right, reflections, and then domain and range. For the first one, when you have an exponent that is backwards, okay, you can rewrite that exponent. I'm going to put it up here as negative x plus 4, which can be rewritten with a negative 1 factored out, and then an x minus 4 inside that. Now, because of that, that is changing the horizontal translation from left 4 to right 4. If you look at what's in the parentheses. Remember, when it says minus, it goes to the right. When it says plus, it goes to the left. So because we can do this process, this is being translated to the right 4, and there is a reflection because we were able to factor out a negative. If you can take a negative out of the exponent, or if there's a negative sign in front of the x, then that means it's reflecting horizontally. So it's a reflection across the y-axis. The plus 5 is a vertical translation, up 5, because it's plus. And then the 0.5 is a vertical compression. So remember, anything in between 0 and 1, that's a compression. Anything greater than 1 is a stretch. Then we have to talk about domain and range. This is an exponential function. So the domain of an exponential function is always all real numbers, and we're going to write that in interval notation.
Does it have to be like this on the test too?
An interval notation?
So it cannot be all real numbers, can't write the weird with an R?
Correct. The range is either going to be greater than your asymptote or less than your asymptote. So remember, exponential functions are like growth or decay functions. So something that looks like this, or decay going the other way. So there's a horizontal asymptote. So your range will either be greater than that or less than that, depending on which way the function is going. This function is technically a decay function, but it is still going up. You know it's going up because 0.05 is positive. If 0.05 is negative, it's going to go down because it would reflect across the x-axis. But this one's going up, which means our range is values greater than our asymptote 5. This guy. If it's reflected across the x-axis, then it would be negative infinity to 5 because it would be going down.
How do you know it's decay?
So it would have been growth because this is a 3, but then since it's reflected, that makes it decay. All right, let's look at the next one. The next one's a log function. So remember, logarithmic functions are inverses of exponential functions. So they have like reverse domain and range. So the domain of an exponential function is all real numbers, whereas the range of a logarithmic function is all real numbers. Okay, and then there's going to be a vertical asymptote that controls our domain. Let's go through all the things first. So first, 3, since it says minus 3, is going to shift this to the right 3. And then negative 6 makes this go down 6. There's no stretch or compression because there's not a number there, but there is a negative sign there. So remember I said if there's a negative in front, that's a reflection this way, so vertically across the x-axis. that would typically affect our range, but since our range is all real numbers, it's not going to affect anything. So the only thing that affects our domain is this horizontal asymptote, which is going to take place wherever the log is equal to 0. So whatever makes this 0, that's where your asymptote is. So what is that?
3.
3. So our domain is either going to be values greater than 3 or less than 3. We want to make sure that the log is always positive. So do we want x's to be bigger than 3 or less than 3? If you look at here. Bigger. Because like 4 is fine, that's log 1. 5 is fine, that's log 2. Log 0 is bad, that's negative. So we want bigger than 3, or 3 to positive infinity.
Do we have to state the asymptote when we do this?
I didn't put that in here, but you can if you want. Questions? Okay. For number 2, you have 2 exponential functions. On the first one, we're going to solve using the one-to-one property. So we're going to try to get the 8 and the 4. We're going to rewrite those using the same base. So what is, oh, I said 4, but it's a 1/4, but they're kind of the same thing. What's a base that I can use for 4 and 8? 2. So we're going to use 2 for these as well. So 2 cubed is 8. And 2 to the negative 2 power is 1/4. So like if 2 squared is 4, 2 to the negative 2 is 1/4. You're going to multiply your exponents together. Okay. And then once we get 2 to a power equals 2 to a power, the one-to-one property says that we can just basically ignore the bases and just set the exponents equal to each other. So we're going to say negative 3x squared equals negative 12. How do I solve?
Divide by 3.
Negative 3.
And then
Square.
square
Root
root it. Square root it. And what do I get?
Plus or
Plus
minus
or minus 2.
There you go. Questions? Okay. For the next one, since we have this 1 here, we can't really solve with that there, so we're going to subtract the 1. That gives me 24. Then you'll attempt to do what we did for number 1, but we can't because there isn't a base that I can use for 24 that I could also use for 5. It would have been great if this 1 wasn't here, then we could have just done 5 squared, but there is a 1 there, so we can't do that. When we can't use the one-to-one property, we use logarithms. We're going to use a log with this base, the base of the exponent, to get rid of it. So we're going to use a log base 5, and these will cancel, and I get just x plus 4 over here, and that's going to be equal to log base 5 of 24. So if that was like a 6, you'd use a log base 6. If it was a 10, you'd use a log base 10. And then you're solving for x, so you'll just subtract 4. Make sure that you don't combine this 4 with the 24, because they're not like terms. And you'll just type that in your calculator and get a decimal. So I get approximately negative 2.025. Are similar in the sense that they're both going to be log equations. This one has logs everywhere, this one doesn't, so they'll be like a little bit different at the end. You want to make sure that you get it as condensed as possible before you try to do anything else. So we're going to combine these two logarithms as one, and we can do that with the quotient property. So because these are the same log, we can write the log of x plus 2 divided by 3 instead of 2 separate. So that condenses it a little bit. And we're doing that because it says minus. If it says plus, then we multiply. We're also going to take this 2 and move it back so that it becomes an exponent of x. That's your, whoops, that's your power property of logarithms. Voila. Once you get it like log equals log or log equals number, then that's pretty much all you can do with the logarithms. So now you're going to take a look at the bases of the logarithms and see what you can do. So what's the base of this log? 10. When there's no base, it's 10. Otherwise, it would say a number there. Whatever the base is, you are going to use that base to eliminate the logarithms. So the inverse operation would be to make those exponents of a 10. These will cancel, and you get x plus 2 over 3. These will cancel, and you'll get equals x squared. To solve this, you should multiply by 3. And this is a quadratic equation. So when you have a quadratic equation, your options are factor, quadratic formula, or complete the square. Before you do anything, make sure it's all on one side and set equal to 0, because you can't solve it like that. I put everything on the right side so that x squared would be positive because I want to factor. So, factoring. Since this is a 3, I'm going to take 3 and negative 2. I'm going to multiply those together. I get negative 6. Yeah, factors that would add to negative 1 would be negative 3 and positive 2. So, rewriting this, I'd get 3x squared minus 3x plus 2x minus 2. So I'm just splitting up the middle term into 2 terms so that I can factor by grouping. My greatest common factor here would be what?
3x.
So 3x and then x minus 1. Greatest common factor here? 2, so plus 2, x minus 1. So my factors are 3x plus 2 and x minus 1. And you want to take those, set them equal to 0, and that will give you negative 2/3 and 1 as your solutions. All logarithmic equations, you should be checking your solutions, because the domain of a logarithm is that it has to be greater than 0. So if your solutions, when plugged back in, give you 0 or anything less than 0, they're not solutions, they're extraneous. So when you plug in negative 2/3, do you get anything less than 0 or equal to 0? Are you sure? What about here? What happens when I plug in a negative 2/3 there? I get log of negative 2/3. That's not good. That one's going to be extraneous. 1 is going to be okay because I get 3 here and 3 there, or 1 there, so that one's fine. So your answer is just going to be x equals 1. This one's extraneous. Not all negative numbers are extraneous, but for the most part that's like a hint that it could be extraneous. Alright, next one we're going to start the same way. Before you put these two together, take this and make it an exponent. You always want to do the exponents first before you like multiply or divide things together. So this is going to be x plus 3 to the 1/2 power. You too. Remember, anything to the 1/2 power is a square root, so I'm going to write that as log of the square root of x plus 3 instead of 1/2 power. And now I'll take those two logs and put them together. So log of 2 times the square root of x plus 3. So we're multiplying because it says plus. In the last one we were dividing because it says minus. And now I have nothing to do, so what do I do?
Cancel it.
How?
10.
10.
So this is a log base 10, so I'm going to use a base 10. What if it's a log base 2? Then I'm going to use a 2. So these will cancel. I get 2 root x plus 3 equals 10 to the 1, which is 10. This is a square root equation. How do we solve?
Move the 2 over.
Yeah, divide by 2. And then
So square both sides.
square both sides to get rid of the square root. So x plus 3 equals 25. And then?
Subtract.
Move the 3 over.
So I get 22. As long as I can plug 22 back in the original and not get something 0 or negative, then it's not extraneous.
That's right.
Mhm. You have to read. Students in an anatomy class took their final exam. They took equivalent forms of the exam at monthly intervals thereafter. After X months, so it's telling you X is what? Months. The average score, S of X, so S is your score, as a percentage, was found to be blah. After how long will the average score be of 50? So they give you the equation. All you have to do is plug 50 in somewhere. Where do we want to plug it in? Is 50 an X or an S of X? It's an S. It's a score. So 50 is going to be substituted in for S of X, your score. And that's going to be equal to 68 minus 20 times the natural log of x plus 1. And then it's up to you to solve this. How can we solve?
Natural log.
It's already in there.
E.
Not yet.
Oh.
Too soon.
68.
Subtract 68. Are you done? Thanks. Okay. After you subtract, please don't do 68 minus 20. That's not allowed. Okay. All right. After you do that, you're going to divide by 20. So I get 18 over negative 18 over 20, which is going to simplify to 9 over 10. Okay, then, now we use E. Once you got everything away from ln and the only thing that's left between the natural log and the E is the natural log, you're going to use E. These cancel, you get x plus 1, and then over here I have e to the 9/10. Your calculator will tell you what that is. Since we're solving for x, we want to subtract 1. So e to the 9/10 minus 1 is our answer. We just have to use our calculator to find out what that is.
1.4596031111.
Whatever. I think I said 3 decimal places, so like 1.60. So the average score is 50 after 1.5 months ish. Questions? No, no, no. Maybe no. Okay, the rest of the word problems, you're going to need to use one of two formulas. Because in number 6, it says, scoot over. It says that the interest is compounded continuously. That is the hint to use PERT. If it doesn't say continuously, if it says something else like annually, monthly, quarterly, one of those, then you use the other one.
I get that you use like E for continuously, but what does that actually mean? Like, do we count?
That's what you're supposed to watch the video on.
How is
To compound continuously means it's happening all the time,
all of
like every millisecond, every instant it is compounding. An infinite number of times compounded. Kind of a weird concept. That's why we use that formula more for things that are like naturally occurring, because naturally occurring things are constantly decaying, like the half-life question. Go through the question and identify what these things are. It says John invested all of his savings, a total of $500. What is that? P. Into a stock when he was 22. What's 22?
T.
Nothing. It's nothing. It's nothing. It's useless.
That's how I was slipping. I was just like, what does it mean?
He wants to know if his interest rate is 6%. That's the rate. Compounded continuously. Continuously means use this formula. After how many years will John's money double? This is a number that's not a number.
P of T.
That's P of T, and you're going to make it double what he invested. So if you put in 500, we want to know when it will grow to 1,000, because 1,000 is double 500. We don't know T. The 22 part is just like for story. Just because it's a number doesn't mean it's helpful.
Could you
Yeah, we know
one and
he's
could you
successful.
could you technically make it 1 and 2, or would it not work like that?
This?
Yeah.
Yes, because the first step is always going to be to divide by 500, and then you just get 2. So yes, you can. So you don't actually need the initial investment. If it says the word double, you can make it 1 and 2. Good observation. After you divide, you use the natural log.
Yay.
So I get the natural log of 2 equals 0.06t. And then divide. I like how like Annika is my go-to talker today. You guys are quiet. So natural log of 2 over 0.06 is t. And you're just going to go to your calculator and be like, hey, Mr. Calculator, what is that?
A number. 3.506557
I got 11. Did you put the 0.06 in the parentheses by accident?
Yeah.
Yeah, I did. Cool.
So in about 11 and a half years, John's money will double. Alice invests $4,000 into an account that earns 3.5% interest compounded monthly. How much will she earn in 10 years? Now, monthly
It's
P
means...
parentheses 1 plus R of N, blah, blah, blah.
Yeah, so we're using the other formula because it says compounded monthly. Monthly is telling you N. It says monthly, it's happening every month. There's 12 months in a year, so N would be 12. If it says annually, it's once. If it says quarterly, it's 4. Semi-annually is 2. You get me? Okay. So we know the N. We also know the principal is $4,000. We know the rate is 3.5%. We're going to write that as a decimal. That's going to be 0.035. And we know time is 10. What do I put on the left?
Nothing.
Well, I got to put something there.
P of T.
P of 10. Because we know that this is the amount after 10 years. this isn't really an equation, okay? You don't have to solve anything. All you have to do is plug all this in on your calculator, and the calculator does the rest. So know when you have to solve and not solve. When we're solving for the left side of the equation, you don't have to like do math. You just, the calculator does all the math. So you just want to make sure that you carefully plug this in a calculator, and the calculator will calculate
How long would that take to do like without a calculator?
Very.
A while.
forever, 120 years. Take me forever. And because this is money, we're going to round to the nearest cent. And we're going to put the dollar sign in front of the money.
As usual.
What if it was cents?
So Ben bought a BMW for $75,000. It's depreciating
Minus R.
at a rate of 10.5%, compounded annually. We're using that same formula, but we're going to modify it
Minus.
for depreciation. And because it's happening annually, that means that n is 1, and that basically means we don't need n at all. So we're using like a modified formula. So if the car starts out at 75,000 and then depreciates to 55,000 at a rate of 10.5%, how many years will that take? So we're going to solve the equation. First thing to do is divide by 75,000. So what's 55 over 75? It's going to be 11 over 15. At the same time, I'm going to simplify this to one number, because why not? Now we're solving for t, so how do I get t by itself here?
Divide. No. Natural log.
Similar to that, but not quite. I can't divide because it's not multiplication. Log was the right idea. What kind of logarithm do I want to use?
Just a regular one.
Natural.
Regular
A
one.
regular log with what base?
0.895.
Right. So when you're trying to solve for an exponent, and there's a number here, you're using a logarithm. You can't divide because it's not multiplication. You're using a log with whatever base the base of the exponent is. So you're using a log base 895, or 0.895, so that these cancel. If this was something else, like 0.8, you would use a log base 0.8. But you're using a log with a base that is the base of the exponent, so that they cancel and make 1. In theory, you can use a natural log, but it's harder. It takes more steps. And that's what we're going to type in. So log base 0.895 of 11 over 15. So 2.796. And this is in years. So in about 3 years, Ben's car will be worth $55,000.
That's a large amount of money gone.
I know. A hepatobiliary scan of Eric's gallbladder involved an injection of half of a cubic centimeter of technetium-99. This is a typo. Which has a half-life of exactly 6 hours. So they put some stuff. They injected him with some medicine stuffs.
Delicious.
Has a half-life of 6 hours. How much radioactive material remained from his gallbladder scan after 24 hours? I don't know if any of you have ever gotten like an MRI or CAT scan or anything like that. They put like contrast in you. So apparently when they scan your gallbladder, they inject you with some radioactive material. But it's fine because it's got a half-life of only 6 hours. So it's gone in like a day.
You have to do that anyway whenever you take an MRI. Except then it'll show up on the scan.
Exactly. So I guess it's like the same idea, just
It dyes the cells so it pops
different
out.
type of scan. But the same concept. So basically, we're trying to figure out how much is left after a day. It's going to be a small amount because if it's got a half-life of 6 hours, it'll be gone in a day. You need to first calculate R, which is going to be your decay rate, and you use the half-life to do that. So this is a two-part question. I'm dividing my little cube into, or my square into two. Part one, we're going to find R. The 1 life decays to half-life in 6 hours. I'm using PERT. Now it must solve. How do I solve?
Log natural.
Log natural.
1/2 divided by 6 is 1.
Okay, and then I divide by 6. And whatever the natural log of 1/2 over 6 is, that's my R.
What is that?
The weird number.
0.116 negative. That's approximately 11.6% per hour. Now, how much is left after 24 hours? So, we are finding the amount after 24 hours. We know we started with half of a cubic centimeter. So my initial amount is 0.5. E to the negative 0.116 times 24 hours. And all I have to do is plug that into my handy dandy calculator. So I get approximately 0.031 cubic centimeters. That's like 3/100ths of a cubic centimeter. That's a very, very small amount.
Not cool.
A certain type of bacteria, a certain type of bacteria doubles in population every 6 hours. That's gross. Given that there are approximately 100 bacteria to start with, how many bacteria will there be in a day and a half? Again, 2 parts. Step 1, we will find the growth rate, because this is different. It's doubling in
Disgusting.
6.5 hours. So 100 bacteria will double to 200 in 6.5 hours. And your first step is going to be to divide by 100. So Sam, like you mentioned, you could just use 1 and 2. You don't really need the 100 at all to find the rate, because it's really just a ratio. Okay, and then after this, we will find the natural log of both sides to get rid of E. And then divide by 6.5, and that will give us our growth rate. So I get 0.107 approximately. There's a little bit of a tricky part in this question because it says how much bacteria will there be in a day and a half, and it says that it doubles in
36.
hours. Yeah, so your rate that you calculated here is per hour, which means you need to make a day and a half hours. So this is going to be 36 hours. You're not going to plug in 1.5 for T, you're going to plug in 36 hours. Whatever your rate is, that's what your time and your rate, they're friends. They have to be in the same units. So this one I threw in there just to get you guys to like pay attention to what you're reading. Usually it's easy. It's years and years or months and months, hours and hours. Put this one in here so you'd pay attention. So we are calculating the amount of bacteria in 36 hours, given that the initial bacteria were 100 and they're growing at a rate of 0.107 per hour for 36 hours. What's it gonna be?
32.
Two. Should be bigger than 100.
7. About 32.
4,708.
Wait, I didn't get that,
Oh no.
but I got close to that. Did you use the same rate as me?
Yeah.
0.107?
Yep.
Or 106? Oh, no, I'm wrong. I typed in 0.106.
Ooh.
You are right.
Oh,
4,708.714.
It's crazy how it's like 1 decimal makes a difference.
I know.
It's crazy. That's why there's like very specific instructions about rounding on your test. So read directions.
2. 3 decimal places.